Welcome to another episode of My Weird Prompts, an AI-generated podcast featuring the random prompts of Daniel Rosehill as answered by a revolving cast of friendly AI characters. Join us for deep dives into AI, technology, and whatever other random thing Daniel finds fascinating today. Subscribe on Spotify or your favorite podcatcher. Now, today's episode.
This episode was generated using artificial intelligence. Please verify facts.
Hi, Herman and Corn. So for once, one of our obscure topics has become a major one, where I'm talking about the air pollution in Jerusalem and Tel Aviv, which was the highest in the world just a few days ago. And I'm looking out at the sky again, and we are back to that kind of sandy type smog that we've had. It was, the AQI was really, really high, and I've been using the excellent IQ Air app. I have a little widget on my home screen now, and it gives me the reading, and it's mostly been moving in a good direction, which has been nice, but it's nudged a little bit back up. And I think that the meteorological reason why we ended up with such incredible air pollution over the past few days was, as is often the case, a confluence of factors and not just one. The ingredient was the sand from the desert blowing in, but then what really got us was the fact that it got stuck. Very calm over the past few days and not much wind at all to move it about. So it's kind of stuck here, and of course the elevation of Jerusalem being on this kind of elevated plane. So when I'm reading about the air pollution, a lot of the commentary mentions the current wind conditions as making it more smog-like, because it's just kind of, it got here from the desert and now it's just kind of stuck in the atmosphere, as it were. So what I'd love to ask Herman and Corn is, when we think about really bad air pollution as it exists in certain parts of the world, we think about smogs. I remember growing up visiting my uncle, who lives in London quite a bit, in Highgate, which is a kind of elevated part of the city. You can look down towards the city of London and Westminster, and he had quite a tall house, and from the top floor, I remember that you could look down literally at the smog and see it over the city. And as a young asthmatic even, it was a pretty scary thing to see. Oh my gosh, there's so much pollution in the air that you can see it. I know some Chinese cities, there is kind of a perma-smog. It's there all the time. So what I'd love to ask about Herman and Corn, because we've been dialing into air pollution quite a bit recently, and this idea that air pollution isn't just a nuisance, not just for asthmatics that have a harder time breathing. It literally costs lives. When we look about how PM 2.5 makes it through our body and is connected to all these problems. Let's talk specifically about the problem of smogs. Certain we can't control the weather or the elevation of major cities. That's where they're built and that's where people live. What causes it, and are there any human ways that have been explored? We've seen these kind of wild technologies over the years, like cloud seeding, for example, to try to actually alter the natural course of weather. For cities that might be more prone to smog, where we have that problem, is the solution simply saying in certain places we don't have traffic? And the final thing I'd like to ask, I know this is a lot of questions in one. One of the interesting things I read about in this air pollution was it talked about the chemical relationship between vehicle emissions and stuff like sand as we have at the moment, and that sometimes when you get these really bad spikes in air pollution, it's not just one pollutant, it's actually a couple of things mixing, and when then you add still winds, you get that worse. So I'd love to understand a little bit more, Herman and Corn, about that kind of chemical cocktail happening in the air above us all the time. We've looked at sort of vehicle emissions, we've looked at sand in this part of the world and other pollutants in others. But what are some second order effects, as you always call them, where you have these major pollutants that are actually combining to make the combined pollution worse than any one of those constituent elements? Herman and Corn, let's continue our deep dives into the fascinating topic of air pollution and smogs in today's episode.
Hey everyone, welcome back to My Weird Prompts. I'm Corn, and I'm looking out the window right now at a sky that looks more like a sepia-tone photograph than actual Jerusalem. It is Tuesday, February 17th, 2026, and the air out there is thick. It is yellow, it is heavy, and it is definitely not just a foggy winter morning. It feels like the city has been wrapped in a dusty wool blanket.
Herman Poppleberry here, and yeah, Corn, it is pretty grim out there today. Our housemate Daniel actually sent us a voice note about this earlier this morning. He has been tracking the air quality index, or AQI, on his phone, and apparently Jerusalem and Tel Aviv hit some of the highest pollution levels in the entire world just a few days ago. We are talking about numbers that rival the seasonal peaks in New Delhi or Lahore.
It is wild. You can almost taste the air, which is never a good sign. It has that metallic gritty quality to it. Daniel was asking about the mechanics of this, specifically how the desert sand from the Sahara or the Arabian Peninsula mixes with our local traffic emissions to create what he called a chemical cocktail. He wanted to know if this is just a natural disaster we have to endure, or if there are actual human-led ways to fix the sky.
It is a perfect metaphor, honestly. We often think of air pollution as one thing, like smoke or dust, but what we are breathing right now is a highly complex reactive mixture. It is not just additive, it is synergistic. In chemistry, synergy means the combined effect is significantly worse than the sum of its parts. When you mix urban exhaust with desert dust, you are not just getting dusty exhaust, you are creating a whole new class of atmospheric toxicity.
So, let us break this down. When we talk about smog, the word itself is a portmanteau of smoke and fog, right? It comes from the early 20th century. But the modern version we are seeing in cities like ours in 2026 is a lot more sophisticated than just coal smoke from the 19th century.
Exactly. The classic London-style smog was mainly sulfur dioxide and smoke from burning coal. That was a reducing smog. But what we deal with today is mostly photochemical smog. This happens when sunlight reacts with nitrogen oxides and at least one volatile organic compound in the atmosphere. Nitrogen oxides, or NOx, come primarily from internal combustion engines and industrial stacks. Volatile organic compounds, or VOCs, can come from gasoline, cleaning solvents, and even natural sources like certain pine or citrus trees.
And then you add the sand. In our region, we get these massive dust storms, often driven by the Sharav or the Khamsin winds. Usually you would think, okay, sand is just physical particles. It is annoying, it gets in your eyes, it makes you sneeze, but it is just earth. But Daniel's prompt touched on something deeper. How does that sand interact with the vehicle emissions?
That is where the chemistry gets really fascinating and a bit scary. Mineral dust particles, which are what we call the sand in this context, are not just inert rocks floating in the sky. They provide a massive amount of surface area for chemical reactions to take place. Think of each tiny grain of dust as a miniature floating laboratory. These particles are often made of carbonates, silicates, and iron oxides. When they meet urban pollution, they act as catalysts.
So, the pollutants from the cars are actually latching on to the dust and changing?
Precisely. We call this heterogeneous chemistry. When nitrogen dioxide from a bus exhaust hits a grain of desert dust, the mineral surfaces can catalyze the conversion of that gas into other things, like nitric acid or nitrous acid. This changes the acidity of the particle itself. Normally, desert dust is slightly alkaline because of the carbonates, but as it travels over a city, it gets coated in these acidic layers. Then, when you inhale that, you are not just getting a piece of sand in your lungs, you are getting a particle coated in concentrated acids and toxic metals like lead or cadmium that were also floating around in the traffic exhaust.
That explains why these dust storms feel so much more oppressive than just a windy day at the beach. It is like the sand is a delivery vehicle for the industrial pollution. It is taking the gas phase pollutants and turning them into solid phase or liquid phase pollutants that stay in our lungs longer.
It really is. And there is a second order effect here involving sunlight. One of the biggest components of smog is ground level ozone. Up high in the stratosphere, ozone is great. It protects us from ultraviolet radiation. But down here, it is a powerful respiratory irritant. It is formed when nitrogen oxides and VOCs bake in the sun. Now, you might think a dust storm would block the sun and reduce ozone, but the dust can actually change how light scatters through the atmosphere. This is called the aerosol optical depth effect. Sometimes, the way the dust reflects light can actually increase the rate of these photochemical reactions in certain layers of the air, creating pockets of extremely high ozone right where people are breathing.
So it is a feedback loop. The more stuff you have in the air, the more surface area you have for reactions, and the more the light gets bounced around to trigger even more reactions. It is a self-sustaining smog machine.
Exactly. And we have to talk about the physical size of these things. Daniel mentioned the air quality index, which usually tracks PM10 and PM2.5. PM stands for particulate matter. PM10 are particles smaller than 10 micrometers, which is roughly the size of the dust itself. But PM2.5, the tiny ones, are the real killers. They are about 1/30th the width of a human hair. They are small enough to pass from your lungs directly into your bloodstream. When traffic emissions condense onto those sand particles, or when the sand breaks down into even smaller fragments through these chemical reactions, the concentration of PM2.5 skyrockets.
I remember reading that in Jerusalem, our elevation actually plays a role in how this stays trapped. Daniel was mentioning how it feels stuck here. Is that the temperature inversion effect we have talked about before?
It is. Normally, air near the ground is warmer and it rises, carrying pollutants up and away. But during a temperature inversion, which is very common in the winter months here, a layer of warm air sits on top of a layer of cooler air near the ground. It acts like a giant lid on a pot. Because Jerusalem is on a plateau surrounded by valleys, and we have these specific Mediterranean weather patterns, that lid can stay closed for days. The sand comes in from the desert, the cars keep pumping out emissions, and it all just sits there, reacting and getting more toxic by the hour. In 2025, we saw an inversion that lasted for 6 straight days, and the hospitalizations for respiratory distress went up by nearly 40%.
It is a claustrophobic thought. You are literally breathing in the same air that was exhausted from a truck 3 hours ago, just recycled and mixed with desert dust. So, let us look at solutions. Daniel asked if the answer is simply to reduce traffic. On the surface, that seems logical. Less cars, less nitrogen oxides, less smog. But is it that simple?
It is a huge part of the puzzle, but it is not a silver bullet. If you eliminated every internal combustion engine in Jerusalem tomorrow, you would still have the desert dust, and that dust on its own is still a major health risk. However, the chemical cocktail effect would be gone. You would be dealing with a natural phenomenon rather than a man-made toxic event. But here's the kicker, corn. Even if we switch to all electric vehicles, we still have a particulate matter problem.
Wait, why? Electric cars do not have tailpipes.
They do not, but they still have tires and brakes. Research from 2024 and 2025 has shown that non-exhaust emissions, which is the dust created by tire wear on the asphalt and the friction of brake pads, now account for a huge percentage of urban PM 2.5. Because electric vehicles are often heavier due to their batteries, they can actually produce more tire wear than a lighter gasoline car. So, just changing the engine type does not solve the physical dust problem in a city.
That is a point people often miss. We think electric cars are zero emission, but they still have a physical footprint on the air quality because of the friction on the road. So, if reducing traffic is only part of it, what about the more high-tech stuff Daniel mentioned? Cloud seeding. Can we just make it rain and wash the sky?
Cloud seeding is one of those topics that sounds like science fiction but has been around for decades. The basic idea is that you fly a plane into a cloud and disperse silver iodide or salt particles. These act as nuclei for ice crystals to form, which then fall as rain or snow. The theory is that the rain would scrub the atmosphere, a process called wet deposition. The water droplets grab the dust and the chemicals and bring them down to the ground.
I can see why that is tempting. It is like a giant shower for the city. We saw some big headlines about this in the United Arab Emirates back in 2024, right?
We did, and it was controversial. They had record-breaking floods, and while the government denied that cloud seeding was the primary cause, it sparked a global conversation about the risks of weather modification. There are several problems with using it for smog. First, cloud seeding only works if there are already clouds with enough moisture in them. You cannot just create a rainstorm out of a clear, dry sky. During our worst smog events in the Middle East, the air is often very dry and stable, which is why the dust stays suspended. If there is no moisture to work with, cloud seeding does nothing.
And what about the environmental cost of the seeding itself?
That is the second issue. You are not deleting the pollution, you are just moving it. If you wash a massive amount of acidified, metal-laden dust into the ground, you might be trading an air quality problem for a water quality and soil quality problem. Silver iodide is also a heavy metal, and while it is used in small amounts, the long-term cumulative effects of widespread seeding are still being studied. Then there is the geopolitical side. If we seed a cloud here in Jerusalem, does that mean a city downwind in Jordan gets less rain?
Right. It is essentially stealing water from your neighbors. It is a zero-sum game in many ways.
Exactly. Most atmospheric scientists in 2026 agree that cloud seeding is a band-aid, and a risky one at that. It does not address the source. It is trying to manage the symptoms rather than the disease. A more effective, albeit less flashy, human-led intervention is urban design.
You mean how we actually build the city?
Yes. In some cities, like Stuttgart in Germany or even parts of Singapore, they are looking at wind corridors. This involves planning the height and placement of buildings to allow natural breezes to flush out the pollutants. In an ancient, hilly city like Jerusalem, that is incredibly difficult to retrofit, but for new developments, it is essential. We also have smog-eating materials now. There is a type of concrete coated in titanium dioxide. When sunlight hits it, it triggers a reaction that neutralizes nitrogen oxides, turning them into harmless nitrates that wash away when it rains.
I have seen those. They call it photocatalytic pavement. Does it actually work at scale?
It works for the air immediately touching the surface, so it is great for tunnels or narrow streets, but it is not going to clear the sky over an entire metropolitan area. Another natural version of this is urban greening. Trees and plants are incredibly effective at capturing particulate matter on their leaves. Some species are better than others. For example, trees with hairy or waxy leaves like certain types of oaks or even some desert-adapted shrubs are like natural Velcro for PM 2.5.
I remember reading about those moss walls being used in London and Berlin. They have the surface area of thousands of trees but fit on the side of a building.
Yes, the City Tree Project is a famous one. They use specific types of moss that thrive on nitrogen dioxide, but again, you have to be careful with the placement. If you plant a dense row of trees along a narrow street with high traffic, you can actually create a canopy that traps the pollutants at street level by preventing the air from mixing upward. It is called the street canyon effect. It is all about the balance between filtration and ventilation.
This brings us back to those second-order effects. We have talked about the chemistry and the weather, but what are the broader implications of living in this kind of environment? Daniel mentioned the health impact on people with asthma, but it goes way beyond that, doesn't it?
It really does. In the last 2 years, the research has become much more alarming. We used to think of air pollution as a respiratory and cardiovascular issue. But now, we have strong evidence linking chronic exposure to PM 2.5 to cognitive decline. There was a major study published in late 2025 that showed a direct correlation between high smog days and a temporary drop in cognitive performance across entire populations. Because those tiny particles can enter the bloodstream, they can actually cross the blood-brain barrier and cause neural inflammation.
That is terrifying. It is not just your lungs, it is your brain. It explains that brain fog people talk about when the air is bad.
And it is your heart, too. Air pollution is a major trigger for heart attacks and strokes. When those particles cause inflammation in your lungs, your body's systemic inflammatory response kicks in. This can lead to the formation of blood clots or the narrowing of arteries. During these high smog days in Jerusalem, hospital admissions for cardiovascular issues usually spike within 48 hours. There is even research into how these chemical cocktails affect the gut microbiome. We are literally swallowing the pollution as it clears from our upper respiratory tract.
And then there is the economic cost. If everyone is calling in sick, or if people are just less productive because they are physically and mentally sluggish, that adds up to billions of dollars.
Absolutely. The World Bank updated its estimates recently, and the global cost of health damages from air pollution is now hovering around $9 trillion annually. That is nearly 7% of the global gross domestic product. So when people argue that moving away from fossil fuels or restricting traffic is too expensive, they are often ignoring the massive hidden costs of the status quo. We are paying for the pollution in hospital bills and lost productivity rather than in infrastructure.
It is the classic problem of externalized costs. The person driving the old smoky truck isn't paying for the hospital bill of the person breathing the exhaust. But when you add the sand, it becomes a problem that transcends borders. We can control our traffic, but we cannot control a dust storm in the Sahara.
That is a very astute point. And as we see more desertification due to climate change, the dust itself is becoming more problematic. As areas that were once semi-arid become full deserts, we are seeing more dust being kicked up. But it is also about what is in the soil. In some parts of the world, dust storms are picking up dried up lake beds like the Aral Sea or parts of the Great Salt Lake. Those dusts are full of agricultural runoff, pesticides, and heavy metals. So the natural component of the smog is becoming more toxic even before it reaches the city.
So it is a triple threat. It is mineral dust plus industrial agriculture waste, which then meets the city's vehicle emissions. It is a globalized pollution chain.
It really is. And here in the Middle East, we are at the crossroads of all of it. We have the natural desert cycles, the rapid urbanization, and the specific topography that traps it all.
I want to go back to the chemical cocktail idea for a second. Is there any research into how we could disrupt those reactions in the atmosphere? Like, could we spray something into the air that neutralizes the nitric acid, or prevents the ozone from forming?
People have proposed that, essentially, a form of atmospheric geoengineering. One idea was to spray alkaline substances, like tiny amounts of lime or calcium carbonate, to neutralize the acidity of the particles. But the risks are massive. The atmosphere is an incredibly complex system. If you introduce a new chemical to solve one problem, you might accidentally create 3 new ones. For example, if you reduce ozone, you might end up increasing the concentration of hydroxyl radicals, which are the atmosphere's primary detergent, but in high concentrations they can be harmful. Most scientists agree that the only safe way to manage atmospheric chemistry is to stop putting the precursors there in the first place.
It is the old saying, the solution to pollution is dilution, but we have run out of room to dilute it. We have filled up the sky.
Exactly. We have reached the carrying capacity of our local atmosphere. When the weather doesn't cooperate and give us that dilution through wind and rain, we are left staring at the consequences of our choices. It makes me think about the history of this. You mentioned the Great Smog of London in 1952. That was a turning point because it was a mass casualty event. Thousands of people died in just a few days. That led to the Clean Air Act of 1956, which was the first real attempt to regulate what people could burn in their homes and factories.
We are in a similar moment now, but the pollutants are more invisible. It is not thick black soot from a chimney. It is a yellowish haze of microscopic particles and reactive gases.
And the solution has to be just as distributed. It is electric transit, yes, but it is also better urban planning. It is protecting the soil in the desert to prevent it from blowing away, and it is improving indoor air quality. In 2026, we are seeing a huge rise in high-efficiency particulate air, or HEPA, filtration in public buildings. We are realizing that we have to treat the air inside our buildings the same way we treat the water in our pipes. We wouldn't drink water from a muddy river, so why are we breathing unfiltered air from a smoggy street?
This has been a pretty heavy discussion, literally and figuratively. I think for our listeners, the takeaway is that when you see that yellow haze, it is not just a natural event. It is a moment where human activity and natural cycles are colliding in a very physical way. It is a reminder that our bodies are not separate from the environment. Every breath we take is a chemical exchange with the world around us. When we change the chemistry of the sky, we change the chemistry of our own blood.
It really is a shared resource. And while things like cloud seeding might seem like a quick fix, they often distract us from the harder, more necessary work of reducing the emissions at the source and designing our cities to breathe. We need to think about the city as a living organism that needs to inhale and exhale.
On that note, I think I'm going to go make sure our air purifier is running on high. Daniel was right to be concerned. It is a complex problem that requires more than just a simple fix. It requires a fundamental shift in how we think about our relationship with the atmosphere.
Definitely. And it starts with monitoring and understanding. The more we know about what is in that chemical cocktail, the better we can protect ourselves and advocate for cleaner policies.
Well, thank you all for joining us on this deep dive. This has been a fascinating, if slightly sobering, look at the chemistry of the air we breathe. If you've been enjoying my weird prompts and our deep dives into these topics, we would really appreciate it if you could leave us a review on your podcast app or on Spotify. It genuinely helps other people find the show and join the conversation.
Yeah, it makes a huge difference to us. And remember, you can find all our past episodes, including our earlier discussions on urban planning and atmospheric science, at myweirdprompts.com. We have a full archive there and a way for you to get in touch if you have a topic you want us to explore.
Thanks again to Daniel for sending in this prompt. It was a timely one for those of us living here in the thick of it. We will be back next time with another deep dive into the weird and wonderful world of human AI collaboration and the science that shapes our lives.
Until then, breathe easy if you can, and stay curious. This has been My Weird Prompts.
Goodbye, everyone.
Goodbye.
This episode was generated using Gemini Flash 3. Text-to-speech engine was Chatterbox Turbo.
Thanks for listening to another episode of My Weird Prompts, an AI-generated podcast featuring Daniel Rosehill's AI prompts as answered by a revolving cast of friendly AI characters including me, Cornelius the Sloth. Subscribe on Spotify or visit myweirdprompts.com.